Okay, so this is a quadcopter equipped with a Pixar flight controller, and this has a GPS attached to it already, and a buzzer and a kill switch. So the switch is just going to be just for turning on and off in case of emergencies. Let's say the BLDC motor goes out of control, just use it to turn it off completely. And this is the main part of the room, the controller. So this has serial ports, telemetry 1, telemetry 2, USB port, ADC converter 3.3 volts, and ADC converter 6.6 volts. And we have more SPKT and DSM ports, as well as GPS, switch, and buzzer. So these things are going to be used for controlling the whole of the drone. And mainly telemetry 1 is going to be used for extending GPS range, and telemetry 2 will be used for getting the data from all the sensors and then possibly upload it to our computer wirelessly. And if you run out of option to get two telemetries, you can always switch to an option for SD card. You can literally put an SD card here and then get all the sensor data out, and then just put it in our laptop to get an Excel data completely. And then we have FSI6 transmitter for controlling it if you're going to be using a normal controller. This has 4 channels mainly. So channel 1, channel 2, channel 3, and channel 4. So these 4 channels are going to be used for controlling the drone, the thrust, the yaw, the roll, and the pitch. So after this, we have auxiliary channels. There will be 6 channels auxiliary. This is going to be, that is channel 5, 6, 7, 8, 9, and 10. So these channels are going to be used for controlling the flight modes of the drone. I'll be showing that here. And this is mission planner. We'll be using this app to completely configure our Pixar. Let's go to the pitch. So I'm currently connecting to the Pixar. We're going to mandatory hardware and frame type. Mine is X-shaped quadcopter, so I'll be pressing this in order to get it done. It'll be already inbuilt in this, and then go for axle calibration. Inside which you'll be calibrating the axle, basically saying you to
place vehicle level and press any key.
Yeah. So
unhealthy GPS signal.
Okay, so you'll be doing whatever it says here, like placing it on level and then tilting it to left, right. Everything will be done in 45 degrees,
unhealthy GPS
and then click
signal.
when done. So yeah, the next is compass. So compass is the place where you'll be having 3 different compasses, compass 1, 2, and 3. So 1 is going to be for pitch, 2 is going to be for roll, and 3 is going to be for yaw. And if you're going to dismiss one of those compasses, then you'll be missing one of the DOFs. And for radio calibration is going to be the RF calibration.
GPS signal.
That is going to be this. So the radio calibration, as you can see, it's for pitch. Pitch is going to be this, and then throttle is going to be this, and then yaw and roll. And we have the auxiliary channels 5, 6, 7, 8, 9, and 10. And then we have serial ports here. We'll be giving you all the serial ports and data that you can get from there. So you'll be having 5 serial ports in our Pixar flight controller. These can be used to get data, sensor data mainly. And then we have flight modes where you can configure the auxiliary channels. So we have 6 flight modes can be equipped. So within this, you can do these many flight modes available. As you can see, it's like 10 to 15. We usually use stabilize, altitude hold, guided mode, RTL, those kind of things usually. Other things are mostly not used. And then we have failsafe. Failsafe is a place where you'll be having your battery. Like let's say your battery goes down below 50% or 40%, and then you don't have enough battery to make it to the end. So then you have to return back. So even if you are unaware of the battery, it will be returning back automatically. That is called as RTL, or failsafe, return to launch. That happens when the battery level is too low, or if your controller gets disconnected. And then we have optional hardware where you can go for RTK, GPS, and then our battery monitor 1 and the battery monitor 2 will be for the backup battery. And then we have speed controls, rangefinder, all those kind of things. And we'll be having another setup called as advanced setup. That advanced setup consists of terminal and script REPT. So yeah, and then we have the other thing, like let's say for a drone, to control a drone, we'll be using one a normal remote controller, or option two, make it autonomous. And that's exactly what this plan is for. So if you're going to go to plan, right now my gps is not connected, so it's just showing some random location. So let's say we are here, right click, we're going to set this as our home. So set home here, and that home part is going to be the place where you're going to start. So that home part, take off, and altitude should be 10 meters. That's my choice. So yeah, so we keep 10 meters, take off, and then let's say I want to go here, next point, waypoint 1, and then waypoint 2, waypoint 3, and then waypoint 4 is going to be the end point. So that's here, last waypoint. Look at, put and land, and that's literally it. And then if you're going to go ahead and put in read, oh sorry, right here, once you've written right, this format will be uploaded to the Pixoc, and it will be moving accordingly. That is going to the destinations by itself autonomously. And in case there's a fail safe, like battery is going down, those kind of things, it will be returning to your launch in the middle itself. And also do mind, if in case the RTL gets triggered, it will not take the same path that you have put in, it will take the shortest path to come back. And you can save up to like 3 or 4 different slots in your computer itself. It's your choice. And you can change your altitude, and you can also have different frames also here, like relative frame, or if you want you can change it to absolute or terrain. And the terrain is mostly used for our rovers and stuff. This Pixox is also not only used for only the drones, it is also used for other stuff like these. Now the available options for this, we have a 6 wheel car, helicopter, aeroplane, quadcopter, tricopter, 6 hexacopter, and then double quadcopters and octocopter, those kind of things. And there's also an antenna tracker, and then we have an subwoofer official. So yeah, all these things can be controlled using the Software controller. That's it. Thank you.